Hi guys, so here are our practice problems for today. Okay, in each of these we are asked to find what is the x. Okay, so let's look at them individually. So the first problem, if you can see, we have two chords right here. Okay, and notice that the central angle for each of these two chords is the same. That tells us that these two chords have to be the same as well. So we can quickly write an equation. 4x is equal to 2x plus 8 that we can solve. Okay, get all the x's to one side. 2x is equal to 8, which means that x has to be 4. Okay, question number 2. So as you can see, right, BD is the diameter of the circle. And we know that diameter that is perpendicular to any chord, so like this BD is perpendicular to AC, we know that in that case diameter bisects the chord, which means that AE and EC must be the same length. So again, we can write an equation. So 3x plus 4 has to equal 31. Get our constants to one side. 31 minus 4 is 27. Divide by 3. X is equal to 9. Okay, problem number 3. So here we are asked to find how far away this chord that is 8 units long is away from the center of a circle. Okay, so we are going to use the property of a circle that tells us that every radius in that circle has to be the same, which means that distance from O to B has to also be 5. Okay, and again, this line that is perpendicular to a chord has to split this chord in half, which means that if the AB is 8, then this distance right here is 4, okay? And now we can use the Pythagorean theorem to figure out what x is. So 4 squared plus x squared has to equal to 5 squared, okay? Which means that 16 plus x squared equals 25. X squared is equal to 9, and x is 3. Question number 4. So in this case, we are given two chords, and notice these parts of the chords are congruent to each other. So because this is congruent to this little piece and this piece is congruent to that piece, we can conclude that those two chords are equal to each other, which means that the corresponding arcs for both chords have to be the same. So for example, for this chord, this arc is 110 plus 60. And for this chord right here, the same arc is 60 plus, let's call this y. Which you can immediately see that this has to be also 110. Okay. So knowing that the sum of angles around the circle has to, sum of those chords around the circle has to about that to 360, we can write that x plus 110 plus 60 plus 110 is 300. 280, sorry. 280. So that means that x has to be 80. Question number 5. We're given two congruent arcs, and that tells us that corresponding chords also have to be congruent. So that means that 2x minus 3 has to equal x plus 5, and that means that x is equal to 8. Okay, right here, right? If we look at these two chords, right, they intersect each other at the center of a circle. And we also know that these two angles are vertical angles, and vertical angles are always congruent. So because these two angles are congruent, those two arcs also have to be the same. So x plus 23 has to equal 98, which means that x is equal to 75 degrees. Okay, and the last question, how can we find the center of a circle using construction? So unfortunately, I don't have a compass, and I'm sure that a lot of you don't have one either. We're gonna wing it. So the steps are kind of simple. All we have to do is we have to create two chords, okay, that are not parallel to one another. So let's say this one here and this one right here. And then what we're gonna do is we're gonna construct a perpendicular bisector of each chord. So let's try to construct it. So I'm gonna eyeball it. This is, the center is about here. So remember, we would do something like this. We would draw a line, okay? And then we would repeat the process for this other chord. So again, I'm gonna eyeball where the center should be. And remember, we're gonna construct two arcs, one from each endpoint of this chord. Okay, and then we're gonna draw a line. So where the two chords, the two perpendicular bisectors intersect, that's the center of the circle. Okay, and there you have it. Okay, I hope this was helpful to everyone. I'll see you guys tomorrow.